Okay, welcome everyone to today's webinar, Real-Time Data, Real-Time Decisions, Unified Architecture for Modern Applications. My name is Matt Bichelle, Senior Director of Product Marketing here at GridGain Systems. I am joined by Ian Ruffle, Sales Engineer for GridGain, and Nelzir Luises, Sales Engineer for GridGain. Now, before we get started, just a couple of housekeeping things. You will be sent the recording for this webinar after, so if you missed anything or not able to stay for the whole session, you will receive the recording. And we also will hold Q&A for the end. However, please enter your questions into the chat anytime you'd like. So with that, I'd like to give a brief introduction of our presenters. So as I said, Ian is a sales engineer with GridGain. He has over 20 years of experience working on high volume throughput transactions, uh, transactional database backed components for large companies. He's an expert in designing and optimizing solutions for various tech sectors, be it gaming, financial services, telecom, media, broadcast, and transportation. Nell Zier is a sales engineer at GridGain with nearly 10 years experience as a systems consultant and developer and a sales engineer. He's deep expertise in app development, database design, and troubleshooting, and has his solution architect certification from AWS. Now, before we get into the agenda, would like to send you a quick poll. So if we would put the poll up on the screen and just take a quick moment to answer it before we get started. So our first question, how familiar are you with Apache Ignite? So 5 being the most familiar. How familiar are you with Ignite version 3? Again, 5 being the most familiar. And how familiar are you with GridGain? Again, 5 being the most familiar. I'll give it just a minute or two before we get in to our webinar proper. Thank you for those that have given your submissions so far. I see the entries coming in. We'll give it just another minute. Okay, thank you for those that submitted. Very helpful. All right, so with that, I will actually ask Ian to go and get us started. Ian, take it away. You're still on mute, Ian.
I am. Thanks, Matt. So the agenda for today, I'm just going to give you a little bit of background about GridGain and the product and the company, a little bit of background about the demo and how it came about. Then I'm going to hand over to Nelzir, who's going to actually do the demo for you, and a little Q&A at the end. And like Matt said, if you have any questions as we go along, please drop them in the chat. So GridGain. So what is GridGain? So basically, it's a distributed memory-first architecture. It offers a co-located compute. So what that means is you're sending computations to the data rather than bringing the data to the computations. And that can give you sort of orders of magnitude performance improvements. It's a data processing and analytics platform and gives you, low to sub-millisecond latencies. A really, really powerful platform. It's more or less infinitely scalable. The way the cluster scales is horizontally, just adding more nodes into the cluster. So you need more speed, more scale, just add more nodes in, and the data is automatically redistributed around the cluster. We can deploy more or less anywhere from on-premise on bare metal right through to public and private clouds and containerized environments. It's a flexible and durable data model, so we support multi-model, anywhere from strict SQL to JSON, etc. With fully ANSI 2016 SQL compliant, full ACID compliance. And then the configurable disk-based persistence allows you to very efficiently utilize your infrastructure. So have the important hot data that's in memory, very, very fast in memory, and the more historical stuff that's on disk. But both the in-memory and the disk-based models, both are the same. So it really doesn't matter where it is. It'll utilize the most efficient path there. We can also have the ability to involve all the relevant data in your applications. So whether that's fast-moving streaming data for real-time applications, more historical data, maybe you're wanting to compare, the data that's coming into the system with some historical. It's transactional as well, so don't lose any data, and also the ability to do analytical data on that same transactional data, which is a real game changer when you're looking at real-time decisioning and analytics. We can support pretty much any data format, whether that be Parquet files, streaming data through SQL, JSON, etc., etc. So it gives you the most accurate real-time decisioning. So some of the capabilities and the use cases that we see GridGain used in. So transaction processing is a key one. So because we've got this distributed ultra low latency system, it's able to accelerate and scale enterprise applications and very, very large ones at that. So we have customers using applications that go into the hundreds of terabytes. The advanced analytics, so the ability to execute those complex analytics on your transactional data means you get much nearer real-time insights into your data. You don't have to wait until it arrives into a data lake or another system to do your analytics on. We have the ability to do AI ML operations. So there's a vector store in the system, so you can utilize it for those high throughput AI workloads. Then there's another use case, which is the data hub, which allows you to bring in data from lots of different disparate data sources, curate it, potentially do an ETL on it, and then offer that up in a consistent and scalable manner to all of your other applications and workloads. Because we have the persistence layer, we are able to act also as a system of record. And with the full ANSI SQL and the ability to do key value on the same data, gives you real flexibility on the processing of that data, but gives you the integrity, security, and durability you need as a system of record. And finally, stream processing. So we have the ability to stream data in, but also then look at that data as it comes in and potentially do some actions on it. And you'll see in the demo how we're utilizing that feature. So just a quick look at some of the the real-time, the real-world applications that some of our customers are using. So we have quite a lot in the financial services. So people like RBC, Citibank, State Street, and Barclays are doing real-time risk management applications on GridGain. And we've heard many times that GridGain is literally the only platform that they can do that real-time workload on. Smart decisioning. So FICO, AutoZone, etc. So AutoZone's a really interesting one where they're doing real-time stock management and moving stock between their stores to ensure that customers have got the product that they want when they want it. Real-time transactional analytics. So again, there's people like the NSE is the National Stock Exchange in India. They're doing over 1 million ordered transactions per second. So it just shows that the platform can really scale. 360-degree view. So companies like JP Morgan, BNP Paribas, building up that customer 360, pulling in data from lots of different data sources and reconciling that for a consistent view on the data across the organization. And then again, high performance transactional processing. So, for example, ING doing all their payment processing through GridGain, and that has to be very, very low latency and ultra reliable. So move on now to the demo, and just a little bit of background about how it came about. So we talked to a company that have a taxi application in a large Middle Eastern city that was they were looking to modernize and make more resilient. So we actually put this demo together off the back of that, and it needed to be able to scale to millions of rides a day. You can imagine a large city having 10 plus million residents. There's an awful lot of taxi throughput. So we need to be able to handle real-time, fast-moving data, and also make it resilient to our infrastructure failures. So we need to be able to design for failure. So what we used was some publicly available data on the New York taxi service. So this is say publicly available data. It's real data. Available in Parquet format, and so it's an ideal similar sort of size to what we were looking at in the Middle East. So what we're using is that real data fed into the application, but we're feeding it in basically in faster than real time. So 900 milliseconds covers a minute of the real data. So what we're going to see, we'll replay the trips and the trip requests. It's an event-driven simulation, so we've got that fast and real time, which we can also configure. We're using continuous queries for the real-time revenue tracking. So we'll have a look at what that means in a minute. There's also the web application compute module, which we're using for surge parsing. So that's where you've got hotspots of activity within the geography. And then we've got a real-time dashboard that shows some maps and live metrics to give you an idea of what's going on in the system. So the real-time analytics you're going to see is provided by a Go client. So we've got live metrics showing up that are powered by some SQL queries showing things like pending requests, number of trips in progress, etc. And then some real-time heat maps that you'll see where the colors change based on the activity within those zones. And then the surge pricing, as I said, is based on activity within those zones, and that's powered by our WASM compute. And then we also have a revenue chart that's powered by the continuous query. So what that's doing is continually adding up the revenue generated by the taxi. And then you've got the ability to change the refresh on the application as well. So just very quickly, just what are continuous queries? So continuous queries basically monitor the data modifications within a cache. You get all the updated events are propagated to the subscriber, and the system actually guarantees a once only delivery of that event. So you can make sure that you're not double processing data, and it's very useful for things like doing a bit of calculation on the data as it's coming in, or like we're doing here, offering up as a little dashboard. So the WebAssembly compute module. So what WASM is? It's a binary instruction format. It was built to run basically on inside a web browser, a virtual machine. But what that means is it's extremely portable, and it can be used on pretty much any programming language. So this has been integrated into GridGain now, so you can use these web assemblies and basically run your compute jobs very, very close to the data, which gives you a massive orders of magnitude performance improvements. So we can use pretty much any language such as Go, Python, R, obviously Java, C++, .NET, etc., etc. So on that, I'm going to hand over to Nelzir, who's going to show you around the demo.
All right. Thank you, Ian. Let me share this, and you can let me know when that is visible, and we can get going.
Yeah, we can see that.
All right. So thanks again for the background. So here, we're just going to start off with the overall dashboard, right? And this is what is being powered by GridGain, in which we're using all the features that Ian more so walked us through, right? I could walk through just the different components here and what's powering them, and then just so you get a better understanding of what each of these features is exactly powering. So this is a taxi demo sim from a particular day. So May of last year. You can see the date kind of change as we progress through this demo. The free cabs here, more so we have a list of 20,000 cabs. And if they're actively on a trip, either picking somebody up or dropping somebody off, this would adjust the free cabs, right? As long as they're not actively attached to a trip, they're free. So you'll see this adjust, up and down as we progress through this demo. Then we have en route, pretty more self-explanatory. These are cabs that are actively on the way to pick somebody up, requested, and then dropped off, of course. It's just a total tally of all the trips that have been completed. Here, if you're, part of the business, I would imagine this is where, you would love to see increase continuously, and that's the revenue. And that's more so the continuous query that Ian mentioned, in which we're essentially aggregating all the trips that have completed and summing up the total cost of the trip and any additional tip that may have been added by the passenger, right? So this is, calculated or aggregated through all the boroughs and all the trips that happens. And this top number here is just the estimation of that. And then we have this average surge. So if you've, taken Uber or Lyft or any one of those services, I'm sure you've seen prices change as demand changed. And this is what this surge pricing we've created. Pretty straightforward in terms of, how complex these can get on an actual, application. For us is more so how much activity is happening for a particular zone. So this is pickups and drop-offs, and then the time of day, right? I more so picked the busy days, at least in Boston, which are like, 5 p.m. Or that morning rush. And if you're around that time, then there's an additional tack on the surge pricing. And, I imagine, of course, there are other things you can add to have more, business tune surge pricing. But I figured just using trip activity and time of day was enough to at least give you an idea of how these companies are actually calculating these. So that's more so the top layer, the top tiles. And then this left heat map, this is more so activity per zone. And this is a simple query provided by the Go client in which we're just querying each zone and tallying the total pickup and drop-offs. So this heat map changes based on the total amount of activity we see per zone. And it's just more so on the analytics you can do based on the information that you're more so streaming in. This right side here is a heat map more so detailing the surge pricing per zone. So as you can imagine, we have areas that are just a lot more busy than others. We're in New York, so you can imagine this being the airports, right? So JFK, for example, always a lot of activity regardless of time of day. So the surge pricing there is typically hot the entire day. But then you have certain areas like, East New York or Midtown that kind of pick up based on, maybe people going to work or just regular day-to-day kind of people traffic. But that's more so toward the day. And so those have kind of peaks and valleys there. And this bottom graph here, more so detailing revenue by borough. So if you want to get more fine-tuned into, okay, I know my total revenue for the day, but I want to see which borough is actually providing a majority of this revenue, for example. So it's more so analytics that you can use as a business to then kind of make more so actionable decisions on. You can imagine Manhattan, in this case is more so the top, but depending on the time of day, this of course can always change. And then activity, I've just sorted by the top 10 activity, just because we have a more condensed view here. But you will see these graphs kind of adjust as pickups and drop-offs happen. And you can imagine the top two on the left here are the airports, right? So LaGuardia and JFK. And then top 10 search prices, pretty explanatory, just more so query that I sorted by zone. And you can see the zone search pricing adjusts as the simulation happens. So that's pretty much the dashboard, but I guess the beauty of this, it's a summation of what we're doing more so on the transactionals and on the analytics. So we have data coming in, right? And this can be, fed in as key value, right? So you can have trips coming in that have certain attributes such as pickup time, drop-off times, location ID, and this is a continuous stream. So we have our key value API more so feeding that table, and the continuous query is then monitoring any change to that. So as an application developer, you don't have to continuously manually pull a specific table and then react. You're actually fed in this continuous query as it happens. So then all you have to do is then set up what you want to occur after a change happens to a particular table or tables, right? This can be more than one. In this case, trips, as a trip completes, we see that, and then we recalculate the revenue. So that's more so, again, right? Transactional trips feeding in, and then the analytical side in which we're just more so figuring out the revenue as the trips complete. For the surge zone pricing, this is where Ian talked about that awesome compute job that's running where the data resides. So we're not pulling this information client side and then running this calculation. This calculation actually lives on the node, so there isn't any network hops or anything to actually feed these numbers, right? I have this WASM compute job written in Go, but since it is WASM, it can be in pretty much any language that compiles in WASM, right? So this is, in addition, you can do our regular compute API, which is in Java, but giving you the flexibility to do it in any language just kind of opens up the door of what you can do and how. And then hopefully that all makes sense. And Ian, let me know if you think I missed anything, of course. The second piece here is what we call control center. So this, I would think of this as more so a management kind of GUI, right, in which you can track, clusters or, a cluster and track certain stats, metrics, and see how it's performing. But you can also run, queries, right? There's a SQL editor, and you can also see what compute jobs are running on a particular cluster at any time. But you can also set up alerts, right? So if you hit a certain threshold, you can actually send email or text to actual, your DevOps people, so then they can be more reactive, right? So Control Center just is an additional thing that just helps power the GridGain ecosystem. So then you just have more control on the management side. But you can also always come in here and check to see if tables loaded correctly or just quick little simple SQL kind of commands, right? So it's pretty powerful, and it's a quick way to get real good insight in how your cluster is operating. And right now we're pretty healthy, which is good. But if you weren't, you would get kind of, warnings or danger based on what is happening in that cluster. This alerts tab is more so what I talked about, in which you can, configure an alert based on a certain metric, and you can detail it should go to a shared email or a text message. So, you can be more reactive when something is going wrong with your cluster. And then queries, right? Being we are, again, full SQL compliant, right? This is a pretty cool way to just check to see how things are operating in your cluster. Uh, the queries I have here are more so the ones that are essentially powering the dashboard that you're seeing on the other tab. But it's very helpful, right? Especially coming from a place in which we didn't have something like this, in which you would kind of have to take the data out to then, use like a Trino or a kind of Spark to kind of get insights that you can quickly get if you had querying or SQL capabilities. I find this actually extremely useful, right? And here you can actually see your schemas and the tables that reside in that, and you can actually execute queries here. So this top one, essentially, you can do a simple select, give me the boroughs and the total revenue that is actually happening from there, and then you can have more like a aggregate of that in which you can see total trips and then revenue. So this is pretty much everything the dashboard is doing in a more interactive and user-friendly way. But it's showing you just the SQL queries that are powering that. And then I just have, just explain so you can kind of check what your queries are doing. Are they doing table scans? Are they, we have a concept of a co-location key, so you can actually uh, organize your data amongst the nodes so that data that are related reside on the same nodes. So by using explain, you can see if you're actually jumping GridGain nodes to aggregate the data back, or if your co-location keys work in the way it should. So very useful way to kind of tune or check on the status of a potential query that you're running in your application to see if there's any bottlenecks or anything there. And then here I just was playing around, setting up other kind of queries that you can do. This one is just the surge pricing that you're seeing on the other dashboard. And again, just another explain to show how the surge pricing is happening, right? But again, all this done in Control Center, which can be either self-managed, right? You can deploy this on your own infrastructure, or we have a managed version of this called Nebula, in which you can actually use to monitor clusters that you have either managed through us or managed by yourself. And a few other things we don't have to go necessarily too deep in, but snapshots, again, being if you are using us more as like a system of record, you can take snapshots here and you can automate the period or the frequency in which they happen, and you can actually restore, right? We do have point in time recovery with full snapshot restores. Data replication you can set up here as well. And then, yeah, just more admin. You can set up users of who have access to this and what they can do. So, yeah. Let's see. Did I miss anything, Ian? I feel like I kind of was flying through that, but let me know.
Yeah, I think you covered it. Awesome.
Okay. All right.
Anyway, I'm back to Matt now.
All right. Well, I would say let's just keep the demo up for right now for Q&A. And so I'll encourage people to keep questions coming into the chat. So first of all, this is a great talk through both Ian and Nelzir. I think both hearing about GridGain, the demo background, and then the demo itself. I find this to be a very rich, almost a deceptive demo because you've got, and you guys can confirm this, you've got streaming data coming in, you're running continuous queries on it, and then you're running calculations as well. And so you're monitoring it um, using GridGain as well and managing it as well. So I guess the first question is, can you confirm how is the data coming in? Is it in key value? I guess that's the first question, just looking for confirmation.
Yeah. So we have, there's a couple ways to manipulate data in GridGain. You can do either SQL, kind of SQL command, DDL commands, or you can use our table API, which, you can then either, I would think of that more as like the programmatic way of bringing data in. right? So we have a Parquet file of the full day of trips, and we essentially iterate through that, and then we have our table API populating the tables, and then we have SQL then on top of that populating the dashboard that you see here with all the analytics.
And then for the continuous queries, so that was are those SQL queries or how are those queries structured?
Um, in this case, I would think of the continuous query as more so like a pub sub kind of thing. You subscribe to a particular table, uh, and as it updates or deletes or anything happens to that table, you get these events fired back to your application, and then you can react to this any way that you would like, right? So for example, in this case, we're just populating another table, which is the revenue table, by aggregating these events. But you can do pretty much anything with that. Another example would be if you have a intermediate or a temp table that you rely on for other queries, and you have a few different source tables populating that, you can have continuous queries monitoring your source tables to then update this intermediate table. So it's more so a mechanism used so that you don't have to manually check for changes on tables that you want to monitor events for. But what you do once you get those events is entirely up to you.
Yeah, pub sub makes sense. Um, and so is Kafka being used, or is this all being managed with GridGain natively?
Nope. All GridGain. I guess if you were to think Kafka, that could just be a way to kind of ingest. So if your streaming data or trips comes in via Kafka, we do have a Kafka connector, so we could do it that way. But it's in this demo we're not. But many of our customers do use Kafka as like a way to ingest data, or maybe even send data elsewhere.
Perfect. The other notion was about calculations. The dashboard makes it look so easy, like for that surge zone. But in a way, it
Mhm.
almost seems like the calculations are continuous as well, not just the population of the dashboard elements on the borough revenue and the activity, but also the zone and
Mhm.
the pricing. Um,
Mhm.
it sounded like you said that the calculations were triggered, but can you describe a little bit more how that works, both, I guess, in the application and then on the back
Mhm.
end?
Yeah, I would say calculations are triggered. Uh, But the beauty of being able to have them deployed where the data resides is that you don't need to pull the information to your application and then run your calculations there, right? So you trigger your compute job, and then that just makes sure that the computation or the WASM job in this case is run on the nodes, and then the results are just sent back to you, right? So it's just eliminating that network traffic of having to pull all the data to you, run your calculations, and then react based on the results there. But it is triggered, at least in this case.
And so this kind of comes up with the next line of questioning around infrastructure. So what
Mhm.
might people do infrastructure-wise otherwise if they did not have grid gain? So if they didn't have co-located compute, what
Mhm.
additional infra would they need? And what
Mhm.
would kind of be the result, or what would the capabilities be by comparison? Would they be the same? Would they need just,
Yeah,
what?
I would say it more so just introduces more moving parts, right? Or more systems you have to manage. So many systems, right? They have the capability to ingest data and bring it in, either key value, for example, but they don't provide you the capability to run your SQL query or the jobs or the aggregations you want to do on that data so that you can actually action upon it, right? So they're very good at bringing data in, but they're not very good at allowing you to actually run analytics or do much or get much insight into that data. So you'd either introduce another solution, right? Like a Trino Spark, if you're familiar with those kind of analytic tools, in which you have to take data that is brought into your system, kick it out over there, and then generate your insights there. But with GridGain being that we're able to do, the high volume ingest, the key value API, but we also provide you SQL, you are able to run the queries that you are used to or you need in order to provide the insights kind of shown on this dashboard without having to move that data to another system.
Makes sense. Less data movement is better on many levels for many reasons. Um, so this was billed as running on GridGain 9. Are there specific features of GridGain 9 that this demo is leveraging?
Um, I think we've covered a majority of them. I guess the only thing on the slide we didn't really talk about was the affinity keys in which you can actually co-locate the data based on certain IDs. So if I like using the example of, customers and orders, you can have orders for a particular customer all residing on the same kind of GridGain node. So when you run kind of queries, you don't have to go and pull information in a scattered kind of way, right? It's more efficient. So we do use our, affinity keys we call in this demo, which is, GridGain 9. GridGain 8 also supported that, but it's a feature in here that we just didn't really highlight, but it's very helpful in terms of improving performance. Uh, I guess we can go deeper into the differences between 8 and 9 because then that's where you get more of an appreciation of how they're different in the sense of GridGain 8. GridGain 8 was more of a key value system with SQL tacked on top, and GridGain 9 SQL is more of a first class citizen. So and then we do provide key value API into that. But if you're a SQL shop, you will get the best performance in a GridGain 9 based on just how it's architected, if I can say that word. But yeah, I would say the features that are highlighted more on the PowerPoint are the main ones here. Um, but we do have a few others that just weren't just used, at least in this demo
Makes
today.
sense. Yeah, makes sense. Um, Now you started to allude in the control center for GridGain, you started to allude some additional features. Are those, I'm surmising that those are GridGain specific because a lot of people here might be more, based on the poll, or might be more familiar with Ignite, but I presume, that there's some features that you're alluding to
Hmm.
that are more GridGain centric. Could you just kind of just talk about which of those features um, are?
Yeah, I would say, and Ian could probably have more insight here because he's worked with Aiden and Ignite a little longer than I have for sure. But the control center you can use to manage both Ignite, GridGain 8, and GridGain 9. But you aren't able to run through every single feature provide that you see on like the side kind of panel and control center with every version, right? So for example, snapshots or being able to let's see, what am I missing? Snapshots, and being able to recover those snapshots. That's more of a GridGain feature, and not essentially something you can do in Ignite without having to kind of bring down a cluster and bring it back up. So long story short, Control Center is a way to monitor all of those, but based on the version of GridGain or Ignite you're on, there are certain features that you just don't have access to.
Got it. Got it. Look, I think we've covered most of the questions. I've got one more before we wrap up, unless there's any that do pop up into the chat. Is, what was the infrastructure that you used for this? How scalable is it? And
Mhm.
how flexible might it be? Is there anything bespoke or, just to give people an appreciation for, hey, this was super difficult setup, or this is fairly straightforward and could have used any of the above. Can you just describe the infrastructure that you used?
Yeah. So for this demo, I have it running in GKE or Google Kubernetes engine. Uh, but again, being cloud agnostic or on-prem, you can run it anywhere. But this demo, for example, I use the N4 instances in GKE, which are more so like their newer containerized, optimized instances that come with these hyperdisk, which are more performant than your standard persistent disk. Uh, so that's what I went with, just to kind of play around, right? And see how that worked with our demo, and the results are pretty good there. But long story short, I have this running in Kubernetes, but the Google flavor of that, and the taxi sim and this dashboard are also on the same similar hardware, just smaller instances since they're not as resource intensive. Uh, I guess the scaling part. So Ian mentioned you can scale this by just simply adding more nodes to the GridGain cluster. And then, we automatically rebalance there. We do have a concept of vertically scaling, but for the most part, horizontally scaling is typically easier, um, and a little easier to manage in terms of scaling up and scaling down. But we do support vertical scaling as well.
Well, it's good to have that flexibility, but great. All right. Well, look, I think this will draw our webinar to a close. I want to extend a special thanks to both presenters, Ian and Nazir, and to everyone that attended. And again, we will send you a recording of the session. So with that, a big thank you across the board, and everyone have a great day. Thank you.
Mhm.